Yeah, I think I'll start now. There's still people kind of trickling in, but in the interest of time, I guess we'll start, and then we'll fill the other ones in as they arrive. Yeah, my name is Ulrich. I'm the founder and CEO of ObjectSecurity, and I'm presenting about supply chain risk analysis and risk management today. So sort of an often forgotten aspect of information security. And there's obviously an angle on how identity can be used in the supply chain also for tracking and for mitigating and so on. And can everyone hear me okay? Is that working? Yeah? Okay, cool. So this is sort of the very high-level agenda. There's like a slide about us, so you know who I am and my company. And then we talk about supply chain risks, and then about identity and supply chain risk and those interactions. And there's then a case study of a contract we're doing for Navy. And I can kind of outline a little bit how supply chain risk analysis and management is kind of handled there, and how we're using identity and how we don't. And then there's a conclusion. So that's pretty much what we're talking about. And here is me. So as said, I'm the CEO and co-founder of ObjectSecurity. I have a PhD in information security and a master, so I'm kind of, I guess, on the, I used to be on the academic end 20 years ago. Since then, I've founded the company, and that's me. Met a lot of old friends here this week, met some new friends too, like this guy, who, if anyone disagrees with me, then you can take it up with my new friend. And this is what we do. So we do cybersecurity, also supply chain risk. We do data analytics for numerous use cases, like some police intelligence and some other use cases, and also AI, especially around cybersecurity. And I'll fill you in a little bit on that a bit later. So our main security product, and there's only one slide for that. And the reason why I bring this up is because there is, I show in the case study later how it integrates. It's a fine-grained access control product with what we call security policy automation. So it's a unique angle where we make it easier to write policies for large IT environments. So if you think of the bottom being an IT landscape, like say interconnected medical devices, for example, it's hard to write the policies. So our tool lets you use things like mappers and wildcards and so on. So you author these fine-grained access policies in terms that are intuitive to humans, right? The way then the technical details get filled in, and this is then at one is in the picture, is by looking at your environment. So it's picking up anything from network traffic to God knows what other inputs you have, your identity management and so on, as building blocks into your policy, right? So that's, and then you write in step 2 these what we call high-level policies, and in step 3 we produce configurations, technical security configurations, including access rules that get deployed on the systems at numerous layers. So you can think of it like an IDE for policy, right? So this used to be called, and it's a little anecdote here, it used to be called model-driven security. We started this way over 10 years ago, and was like on the hype cycle at Gartner and cool vendor and God knows what. Sometimes these things take a very long time, so now it's still kind of ABAC, and all this is still kind of early stages, or it's not really early stages, but it's not a massive market share. So this seems to be a long-term direction for the industry to go to, right? The bottom half of what we do is related to ABAC. Yeah, I don't want to go into too much details. These are some screenshots of the same stuff. You can see the look and feel. And there's actually 8 steps. There's testing and documentation and all the sort of automated stuff that goes into this, the policy IDE, if you will, that you can use at deployment to get your policies authored and deployed more easily. Related to that, I have a bunch of articles that I'm trying to push on people so I don't have to take them home. So people probably know the ISSA, this is the Information Systems Security Association. I got them here. They're free, and they show a good use case around IoT, where I'm just describing how we do stuff and so on. There's also gonna be a blog post, and you can ask me for get digital copy if you don't want paper. And I got a QR code, so you can point your phone at it, and it's gonna open up whatever link. On the link, there will be a blog post. Anyway, the reason is that I can't go into too much detail about this because we're talking about supply chain here, and the sort of the vertical use case without having time to discuss the actual technology is kind of in 25 minutes. It's kind of a bit of a stretch, right? So let's talk about supply chain risks. There's the supply side, procurement side, which I just took the Wikipedia picture here, so don't bother about the different what's in it, in these boxes. Think of suppliers, contractors, prime contractors, subcontractors. If you're looking at what I call the cyber here, because we're interested in information security, I'm talking about hardware and software procurement. These are not as simple as this. In reality, when you buy a computer, it's like a huge web of complex, dynamically changing supply chain, right? There's the other side too, which is once, say, assuming you're in the middle as a, I don't know, like a Dell or something, right? Then there's the whole logistics side, or Apple or whatever, right? You're in the middle and you're trying to push it then, and this is easy for an IT company because the stuff doesn't spoil and it's kind of clear what it is, you know? If you're looking at things like getting food from a farmer, like milk from a farmer right into your grocery store, this supply chain gets exceedingly difficult because there needs to be guarantees that it's cooled and so on. So supply chains are really difficult. Supply chain risks are also a real challenge here, especially in ICT parts when you're in the information security community, because you know, we have practically no control over the supply chain today, because it's so deep and you don't know where stuff really comes from and who did what and what's. You buy a component and if somebody put something in the firmware or not, you don't know. You're never going to go to, like, I don't know, Taiwan or China or South Korea and check out the factory on a regular basis. You know, it's, even if you have your own factory, it's complex, okay? So what's actually the risk? So the risk is loss of production, for example. These are just examples. It's delays, production interruption. All sort of, in the enterprise world, usually financial losses or unforeseen market developments that hit you. And for, like, especially automotive, you have the recalls issue. So say you have one little bolt, a 5-cent bolt that was counterfeit, and you got a whole pallet of counterfeit, and then the cars get recalled because something falls off. So this can have huge trickle down, or for the, I deal with the Department of Defense, you know, you just need one kind of kill switch by the adversary in one of your devices, and it could have catastrophic effects, right? So this plays a big role. There's also then wrong demand prediction for the just-in-time stuff. Ethical sourcing is one that's been hyped up a lot around blockchain. There's some companies that do stuff where you want to know that the diamond came from a ethical mine or whatever, the coffee was farmed organic and things like that. There's then also the hazard and the safety stuff. I mentioned the produce, for example. You know, if stuff falls off a truck and then warms up and then gets chilled down and you put it in the warehouse, you put it on the shelf and people kind of get sick from it, you're screwed also, right? So why, so that's the what, and then why. This is, so it should be like, why is, yeah, it's kind of a misnomer, the heading, I guess, but I guess the why this happens is, these are sort of triggers of risks, if you will. Is there supplier risks, say change of ownership changes what people, how people's, say, processes work, or their Q&A and stuff like this. There's undesirable events, right? It could be anything. It could be a change of government in some different country. Contract legal sort of, you know, your legal jurisdiction framework might change and it's going to affect a bunch of stuff. A patent, for example. And then I don't know why there's a T failure. Well, I did the slides today, so. So this could be, so it could be geopolitical, or anything related to earthquakes, for example, you know. It could be, yeah, finding the needle in the haystack is impossible. You don't actually know because you're buying some device and you don't know what the supply chain really is. And you don't know what you don't know. Can't really talk about this because we don't know. And everything's fragmented, right? So I'm just giving you, this is not intended to be a conclusive research list, just giving you an idea of what are the triggers and what are the risks, right? So for the military, it's actually kind of a little bit different and the same in the same, different and same, if you will. So they are more interested in adversary sabotage, injection, subversion, to surveil, deny, disrupt, degrade, and so on, the function, use, or operation. So this is very much the kill switch type problem. So this is the Navy's definition. I don't know if anyone else has a different definition. I don't know, but that seems very logical, right? So what can you do to analyze? So we're talking now about supply chain risk analysis. That's the first part, figuring out what's going on, right? So you can, for example, analyze the supplier, and that's really always done, or almost always. So there's vendor management systems where people have to onboard, they have self-certify stuff, that's background checks. Try to sell to the government, you gotta be on some website and somebody's gonna check what you're doing. There's certifications. However, the supply chains are deep, and often what you could call a prime contractor hides you deliberately from all the underlying complexities. The same way, I don't know who built some random chip on this particular computer. I'm not talking about CPU because I know where that came from, but like some random, there's a bunch of stuff in it. You don't know really, and Microsoft in this case wouldn't, there's no way for me to find out, right? So that's really a problem, and there's self-certification issues. And suppliers may be compromised, so they might say something, and actually that's not really what's true because they don't know either, right? You can analyze the item. That's the second big part, right? So test the item is obviously a good thing. If you can do that and if you have the money and the stomach to do it, doesn't really work everywhere. So that's what you do for very critical things where you then don't care, you don't care so much anymore about the supply chain. If you're saying we're getting some stuff and we're exhaustively testing, stress testing this, whatever it is, that it meets our requirements. It's kind of easier for some physical gizmo, like a screw or something, versus hardware and software. How are you gonna exhaustively test a computer, for example? And nowadays, an embedded device is a computer, right? So anything's a full computer, more or less. You can fingerprint the item. I haven't really thought that through so well yet, but when you think about it, many devices would have potentially a unique characteristic. I was like thinking about that more about things like diamonds or something. You would potentially be able to use the reflection capabilities as a irrefutable fingerprint, right? So the same way you could potentially fingerprint some other devices, especially physical devices, because they may be on the X-ray, microscopic, whatever reflection level, I don't know, whatever the physics people can come up with, they may end up producing different outputs, right? It's possible also to embed this theoretically when you do additive manufacturing inside the part, although the question then becomes the structural stability of the part if you're putting like a 2D or 3D barcode inside a 3D printed object, and then it's used in aerospace, and you don't know the specification anymore, right? So fingerprinting works really well with digital items, though, obviously. I mean, we know how to do this. We sign it, we hash it and sign it, and we know what it is, you know. And I don't even need this. I don't need anything. I can redo the whole process and verify that nothing's been tampered with, and that's what it is, right? You can authenticate the item, although that is often not practical, especially with cheaper parts. You're looking at automotive or something like this, or many of the cheap parts that go into a computer. They're only cheap because there's no difference between the parts. And if you started adding a unique identifier into each part, the cost would be prohibitive. So that's a real problem for counterfeit type things, right? So yeah, other factors too, and then you got other factors. So that's the big bucket of looking at what I call surrogates, sort of identifiers to the thing because ultimately you're interested, is my part the part that I thought it is, and is it going to fail on me? Is it the original? Is it whatever, right? Here you're looking at things like shipping. Is the pallet lost and then reappears? Very fishy, you know. Is the shipping path different? So there's shipping paths where it might go from, I don't know, Texas to California, Southern California, and you didn't know it ended up going via Panama because of somebody's mess that they shipped it through the Panama Canal and you didn't know. And then it's exported and you didn't think about it, right? Or, I mean, the paperwork would show it if the paperwork's correct. Right. There's RFID is used quite heavily, and also tracking of container type things. So where you check the temperature and you log the temperatures and things like this. So you know that the containers are that the goods are in the condition in the environment that you think they are, right? There's also an interesting factor that I'm not quite sure if it relates 100%, but when you look at like mean time to failure type things and you say correlate that certain parts keep failing unusually fast and you can track it back to a certain pallet, you would potentially figure if that pallet was shipped by a certain, I don't know, integrator, that maybe other parts in that pallet could have been also counterfeit, and then you go back to these other parts. So it might end up being very non-trivial to trace this back, basically, right? So data sources, quickly, this is just a list. I'm giving you a brain dump here, basically. You have vendor management systems. Obviously, we talked about this. You got procurement systems. ERP is a big one. So SAP is one of the leading, obviously, ERPs. That's used a lot for procurement managing, contract management, logistics systems, and then also product information, like mean time to failure, to trace if something maybe is counterfeit. And what a lot of commercial supply chain risk companies use is public information. So I'm checking a geolocation, all geolocations, whatever, on Reuters or social media to see any kind of earthquakes or bad whatever events that would impact production at one of the suppliers. You know, got the RFID sources, the sensor sources, paperwork. There's always a lot of paperwork to send something, say, from Germany to, I don't know, California. It's like it goes through 20 hands. Everyone has to sign a bunch of stuff. 20 different companies, it's brutal, right? So then you got the item fingerprint type data that I talked about, and if it's a digital item, you could have a signed hash. That's a very good data source, right? Yeah, in my talk, I have little trails, derail trails for sidetracked discussion items. So this is one of them. I'm gonna quickly talk about blockchain here because blockchain has been really hyped up in supply chain management as a good solution. It's basically, I don't need to tell you because it's been all blockchain all week, I guess, a decentralized tamper-proof add-only ledger, right? So why people like that is because you could track every step in the supply chain where everyone that says something dumps stuff in the blockchain and it's add-on. In the end, you have the full trace, right? So turns out it's really not telling you is that diamond really the diamond that you think has been tracked through the whole supply chain, right? Because all you know is that somebody said something along the way. Now, that's as good as it is today, except this will optimize it a lot. So you don't really get much better. You don't have to trust a vendor to run this database because with decentralization and the crypto, you know, you trust the blockchain inherently versus a sort of tracking vendor. But it's not gonna solve ultimately the supply chain risk problem. It's just gonna optimize the process to make it easier and also optimize smart contracts. So this is a good optimization and it could be a data source for risk. I put little pictures there between a centralized model, a decentralized model, and like a centralized, a federated-ish, and a decentralized of how you would get the supply chain to talk to each other. So this is kind of interesting. But the questions are what's tracked, right? Again, so you're tracking just paper. You don't really often know is the good related to the paper. The same thing, I can go to a conflict-free jewelry store and buy myself, which we did, some conflict-free diamond, and I get some paper signed by somebody in Kenya saying something about some diamond that I don't know, some piece of paper, and I don't know if that's actually the diamond we bought, right? So who operates it? Decentralized might help, but there needs to be a vendor, because if whatever, everyone relies on it, you got a lot of issues there, and these are all solvable, but it's just things to think about. And then how to embed the unique IDs. So if you have a digital good, it's obviously easy. That's why Bitcoin is awesome, because the Bitcoin itself is intrinsically tied to the blockchain entry, right? So if I sell you media, some pictures, for example, I can hash the picture and put it in the blockchain, and you can't later, nobody can claim that it wasn't that picture, you see? So that's hard with physical items. And then it's the question, yeah, how to adopt the whole thing. I mean, this is a big bang adoption approach that would need to happen for this. So now the analysis part continued, and then we get on to the management part. Okay, I want to distinguish those two. The first is figuring out what's going on with risk. The second one is what to do about it. So here, practical challenges about the analysis is limited visibility. Quite often, some kind of integrator hides the supply chain from you, unreliable data sources, integration challenges. I mentioned all the paperwork that goes on. You know, everyone has their own system. There's 50,000 systems in the global supply chain, apparently, that are different, home-cooked stuff, and everyone has their own system. So it's pretty, and I don't know if that number's accurate, but I read that somewhere. There are few analytics capabilities, so you don't really have the data integrated. Supply chains are partly hidden. This is what I call surrogate, and I'm sure there's a better term for it, but this sort of other information that vaguely relates to the risk that you're interested in, like how is it shipped and things like that, is kind of unreliable because there's the correlation isn't necessarily clear. just because it was shipped correctly doesn't mean the part isn't counterfeit, for example, or hacked or whatever. And also anonymity may be desired if you're shipping health-related information or whatever, medicinal, I don't know what, you know, it could be, I mean, that was part of what happened with Bitcoin, why that people like that for that reason. So there may be cases of supply chains, especially on the selling end, where you want anonymity. And then there's the skill gap too. The supply chain risk stuff isn't exactly on the top radar of a risk manager. So now a second derailment, since I gotta put all the buzzwords in, AI. So now there's obviously a lot of data, right? So how are you gonna figure out what's going on? Theoretically, deep learning would help you just in general without going into the details. I can do that afterwards if you like. Should allow you to train from past labeled data of risks, data points, data sets and risks, risk indicators. You have enough of those. We're talking here millions of data points. You will be able to train the network to predict correctly future risks, right? AI is broader than that. You could have decision trees and things like this too, which you can code, so you don't have to go deep learning. Deep learning is like the holy grail here, because you need so much data, which most likely you don't have. Incidentally, I gave a talk last week about AI and cybersecurity. Yeah, talk to me afterwards if you want to know. Don't really have so much time, but what's interesting is we have AI for cybersecurity, weaponized AI, and attacks on AI. These are all different angles, and people aren't really thinking about that very much in our community, that weaponized AI is a very powerful tool. So if you're thinking that AI is going to solve your problems, you got to think that it's going to solve the attacker's problem much quicker, most likely, right? And the system can be attacked. So anyway, now to the management part. And this is going to be, I guess, relatively short and sweet here. So you want to do a risk analysis of all the data. How are you going to do that? How are you going to aggregate all this information, right? So there needs to be tools out there that do that, and you don't often have those. In fact, most of the time you don't, right? Because there's many systems. There's your vendor management system, there's your logistics system, there's your ERP, and so on, right? You can test the items. That's the best if you can afford it, and if your item is critical, that's what you do. That's what you do also when you have a sort of mission-critical part at the aerospace or defense end of things. You just have to do they take your part, and then some trusted defense contractor does a common criteria thing for whatever, half $500,000 or something to figure out what's going on. You can do supplier walk-ins. You can refuse items that look fishy and get something else, or change and debar the supplier, for example. So talking quickly about identity, there's only one slide really. Is it a risk indicator, right? So for suppliers, how deep do you go? For logistics, again, how deep do you go into your logistics with the RFID? Is our RFD an identity now? Well, it depends how you track it, right? With products, you don't have identity usually unless it's an expensive part, like a full computer might have a unique baked in. It's got it in the BIOS, for example. Documentation, there's a lot of documentation, so there's identification there. And what does it really tell you, right? So this part on the right is what's your bread and butter as identity community. I don't have to cover that really. You have a lot of suppliers, partners, customers, and so on that need to tap into your systems, and you have to do things like federated identity and single sign-on type things to get your suppliers and partners and everyone tap into those systems so they can provide information. I don't want to cover that because that's kind of clear, right? So there's a project that we're doing, and I have only mainly screenshots here. That's a supply chain risk analysis management system for Navy. We're doing this in San Diego. Their challenge is exactly the insufficient visibility into their it's called Navy ERP. It's a SAP system. There's silos, security restrictions. There's no central capabilities for search in the system, and you cannot test every part. So this project that we're doing for them is about identifying risks from these internal, the procurement data that they have, and from some third-party feeds. There are a bunch of components. They kind of don't matter here. I guess it's a classic database, middle tier front end with some analytics daemon kind of design, and we have our OpenPMF product in there for security, for fine-grained attribute-based access control. Here you can see ingestion into a graph. So what the picture basically just says is we're taking 41,000 columns of an SAP data dump and turn it into a graph that we can search and analyze. Here's a few screenshots how you would search. They're not intended to be gone through in detail, just a look and feel. It's a very simple kind of user interface, right? You look through the data, you find some risks that the algorithms detected. It's all configurable, so which buttons you can see as which kind of role is all configurable. As I mentioned when we started the OpenPMF product, the security policy automation product, so that's used for fine-grained ABAC here, even down to the level of UI elements, which buttons can you see, which menus are available to you, and across the stack from the database, right, through the whole 3-tier application. So that's pretty much what that is. You can see that here, so this is a graphical editor for the policy, which we don't have to go into detail again, because it's pretty technical. There's stuff also in these journal articles that I have here. You can see a bunch of buttons, for example, here, where the rule here would be the power user has access to those particular buttons, and that was generated by the tool and get pushed out with a JSON, a config JSON into the actual product. So it's sort of an IDE that configures the fine-grained permissions for your product. So conclusion, I think really the takeaway is identity plays some role sometimes, and you can't take identity as a given, especially because you often don't know what the identity of a part is if it's not uniquely identifiable reliably, right? But related to all the partners and so on, so that's the sub-bullet, you need to do the usual IAM, like the bread and butter. It's not anything different from anyone else. In fact, you have more power onboarding your partners and suppliers than in many other environments because you're dealing with B2B, and you're kind of, you know, it's a web that is known, and you can onboard people and offboard them and stuff like that. The container tracking type identification, there are products and vendors out there, and that needs to be just aggregated too. And maybe you have identities on the parts if it's some computer, full computer or something, but you will not have it for individual chips or something, right? So you don't know, and also you don't know just because you know an identity doesn't tell you there's no supply chain risk. So that's important. Just because somebody, like I mentioned, somebody in Kenya in some mine, or somebody signed some paper that looks like it may have come out of some mine in Kenya, doesn't tell you that the diamond that you hold in your hand is actually from that mine and has anything to do with the paper that you just got that says it's conflict-free, right? I mentioned blockchain, so that's for optimization of supply chain and decentralized trust. Now for digital items, that works really well. That's why Bitcoin works really well. For physical items, again, it's the same problem. You don't really know what you're tracking. You're tracking a process in the hope that it gives you an indication of whether there's a risk with the item, right? So that works. It's a nice plan B if you don't have uniquely identifiable items. And AI, I just need to put this as a last bullet. There are the usual challenges, so don't see that as a silver bullet right now either, because the data and the features are always the issue. That fits into any AI talk, by the way. Where do you get so much labeled data from with the right features that you'll be able to do deep learning? It's a good question, right? So I will be putting this and a blog, whatever the slides, and a blog post up at Identiverse. In fact, there's a thing so you can, if you don't want to type it in, you can just take the QR code that'll summarize this. And as said, this is a SBIR Phase II with a research government project that we do for Navy in San Diego. So we have the actual data dump. So this isn't a theoretical exercise. We can see what you can get from surrogate data of what you're really interested in, because you do not have unique identifications and unique fingerprints of every device. But you know, if the price, for example, is 10% and nobody has it, but one vendor has it and it's only 10%, it's kind of likely that that's a counterfeit or refurbished part, right? And you will potentially refuse it based on your price history that you know and the fact that it's cheap and the vendor that you didn't think is the one that you got the part from. And that concludes my presentation. I kind of started late and finished late. Yeah, I don't know. I don't think we have time for questions, probably. Yeah, thanks very much. And there's these articles here. So thank you. If anyone wants the thing, I don't want to take them home. Please take some. So they're kind of heavy. Thank you.